like to split this discussion into three. One is to create a framework on which how we should be looking at the urban lakes and what kind of ecosystem engineering we should be doing on that. What has been the effort in the past and any lessons that we have learned. The second one would be about how all these cumulative experiences were used to design the Yelahanka Puttenahalli Lake bird preserve. And we have been now monitoring this for over a year, a little more over than a year. And the third one, we would like to share with you what has been our learnings from Yelahanka Puttenahalli. So with me is Seema Sukhani, who has been a very committed researcher, and because of her, we have learned a lot in the, we collected a lot of data on the lakes. What I will bring to you today is somewhere between 1990s to now, what have been the epochs or epochal experiences that has happened that has changed the way we look at. And this is predominantly my personal experience because I had been part of various groups that had tried to do something. What you see in the background here is deliberately in sepia. That's the, if you see the promenade of on your left hand down here, I don't know if anybody is as young as I am listening. Many people would have done their courtship on this part of the lake. The Halsur Lake, which has received a lot of efforts on trying to go around restoration. So what I'll do today is to bring out together what we have planned and carried out as a society. What is the significance of the path that we have taken and what we've learned? Where are we heading? Towards this, a lot of questions that you would like to ask is what legacies of these restored lakes in the past. Some have been a happy situation, some not so happy, especially where there is sewage ingress. Are all the issues addressed or something been neglected? And what is it that we can sensibly dream of from these learnings? And why has it not been a runaway success where so many people have tried? There are hundreds of efforts. I'm going to bring out maybe 8 or 9, but why have not all these become runaway success? So there appears a difference between the dream and reality. That outcomes I would like to bring out. And what are the ecological and environmental issues that have not been addressed? As you see in the early stages, you find people who are simply cleaning up the lake, looking at it as a engineering problem and bringing it back. But over the years, we find that we have to also address it in a multidimensional way. So the question that we need to ask is how to do it together. Do we have the wherewithal for this? What will be the risks that we need to tackle? Anything new that we try will have certain amount of risk. And what are those risks? Can we put them together? And is there a happy ending to this story, or like any other romantic story that we see? Can we ever live happily after at some point of time? Or are we forced to do this effort continually, evolving new techniques, overcoming newer problems that are likely to come? I'll take you to a couple of these things. These are my personal experiences. So the first peak I would like you to see is into the restoration of the Lalbagh Lake, which happened somewhere between 1998 and 2002. Much of this text has been picked up from the website. Because we knew that lake was highly polluted. There was a lot of sewage getting in. And this is the first effort where you find that the silt or the debris that has accumulated in the lake has been piled up together and made into islands. And also this is the first time you are augmenting the lake water with sewage, treated sewage, especially from a 2 million liter activated sludge and extended aeration type of process that's there in Lalbagh. So what very clearly becomes evident is that this is the first time there is a realization that it is not adequate to use secondary treated wastewater. You need to polish it. For the first time, we use vetiver or the cuss grass and as a flow through and not as a constructed wetland. But what is important here is that this has been now working for a very long time, and that's an interesting starting point. The next thing where I got some exposure was on the both Madiwala and Hebbal lakes in the period of 2002 and 2006 when the Indo-Norwegian Environment Program was started. And both of them attempted to remove or excavate the silt that is accumulated silt and sludge, pile it up into a set of islands because this gave the lowest cost in from the engineering perspective. So the other part was to make sure that the lake was reasonably deep, at least uniformly deep, over 2 meters. Now this sort of gave an experience that, it is very easy to remove the floating weeds. And when you keep a depth of more than 2 meters, then you don't have any emergent weeds. And as you see in the picture here on the left, for the first time, L&T company was there in near GKVK. They also participated in from Jakku. They modified their excavator to pull out. So instead of having a bucket, they had a mesh. So you could pull out that usual 5 tons. It made it very efficient. So you find the company also making this work better. So Hebbal became a first place where these kind of experimentations were done very nicely. But what you see in the picture is not Hebbal. Unfortunately, this is Loktak Lake in Manipur, where I was also involved in that part, and a similar experiment has been done there. The lake, the original plan was that the treated water would get into the lake, and this would meet the evaporation losses. Most of the time you find that in urban lakes, it was important to keep the water level reasonably high, mainly because the system did not want encroachment on the lake. So if the water level is always high, then you don't find people encroaching. But unfortunately for Hebbal, the location of the STP went downstream, so sewage continued to enter this lake. Let's look around the same time, around 2004 to 2007, the Belundur system, Belundur lake began to come into the news. You see in the upper front where it's marked A, already in 2005 you have a large number of multi-story buildings coming up, and this part of the Bangalore did not have underground sewerage system. And you also find in 2005, for the first time, you find a lot of froth coming out of both outlets, the northern and the southern outlets of the thing, one near the HL and the other one near the village, old village of Belundur. So you find that in the outlet is frothing, and there is organic content in the water. There's an uncontrollable weed infestation. In this period, it was mainly water hyacinth. And the Lake Development Authority was looking for a solution to this problem. And especially because there were threats from various regulatory bodies, you find that the KSPCB, the Departments of Mines and Geology and then the BMP, Bangalore BBMP now, were looking at various forms of regulatory issues, and but nobody seemed to have a problem. LDA or BBMP were trying to resolve the problem, but there was a lot of confusion because nobody was trying to give any realistic solutions. Many of them had magic bullets, and there was hardly any expertise to resolve this problem, especially on the froth. Nobody understood why this froth was coming. And also, it was not very clear how much of sewage was actually entering the Belundur Lake. Especially what was coming out was from the KNC Valley treatment plant and also from the habitation around. Interestingly, around this period, the groundwater was found to have 200 milligrams per liter of nitrate, and that raised an alarm. In those days, the limit for nitrate was 200 milligrams per liter. So this seems to have raised a large amount of at least a clarion call for waking up. And now it was clear that the sewage was ingressed, was coming into the lake from in and around Bangalore, Belandur, and mainly from the habitation around and some from the soak pits. So what you find there is people trying to evolve some very simplistic solutions, at least the early stages. I'm not putting that down, but what I'm saying is there were no solutions, but people are looking at very simplistic solutions. And now from hindsight, we realize it used to be very difficult. And nobody articulated that it was the modern detergents that created the foam. So what you see on item B is that is the foam coming out, froth coming out because of detergents and the white foam. But you see on the next one where it is C, the item C, the input sewage is not frothing at all. So this was a mystery, what was happening there. And so the solution given was, since things are not getting degraded, there's a lot of BOD coming out. So the easy way was to understand that the algae in Belandur Lake was not doing its job at night, which of course it was not supposed to do anyway. So we'll aerate it. And then you find in under the picture D, where you have floating aerators put into the lake, and you have diffuse aerators, something like one aerator per hectare. Of course, it was not adequate, but it was supposed to increase the DO level in the lake and keep the system functional so that even in the night, biodegradation took place. The next important epoch that I have seen is from the Agara Lake. And it's for the first time you'll see that it's a reasonably well-engineered idea. So what you see on your leftmost point where A, you find the drain that is taking away sewage into from Jayanagar side into the Belandur Lake through this drain. And you see the wall in which there's a small weir made. The wall is designed in such, the weir is designed in such a way that under normal flow, the sewage will pass through it and go away. Whereas in case, sorry for that, I forgot that I should switch off these mobiles. Yeah, when the storm flow happened, then this weir was not enough. I guess that time about 5 to 10 MLD only was flowing in this particular channel. But when the storm flow came in, then you will see that this water would rise along this height. And once it rose in the height, once it rose above this level, then you would find that this 8 to 10 inches was given for intake channel to the Agara Lake. So here you find that this is about 12 feet wide and 8 feet tall. You find that when the water level rose here, and this weir was not enough to, but was not enough to to allow the water, then it would come through it, the intake. And here you had a sluice gate that you could decide whether to take it in. Obviously, this channel would have been full of plastics, paper, and other non-decomposables. So you had to have a boulder bed to filter it out. And then a second was, since also some sewage would have come in during the period, this part, it would stay for about a day or two when a lot more decomposition would take place. And then it would pass through this barrier in which it blocked all the large particles, and a whole set of about 2 to 3 acres of typha, which would in turn slow down and remove all the silt as well as break down, pick up a lot of nutrients. So what you see for the first time is a reasonably well-engineered, well-considered situation. This is circa the same time as Belandur's first problem, but this Agra was a smaller lake to deal with, so it was much easier to design. Then you find that there is a mechanism for segregation of sewage and runoff, although they flow in the same channel. And this is something very, very interesting that has happened in that period. And whatever comes in has been cleaned up, and it's not using the conventional wastewater treatment mechanisms. There's isolation of plastics and the floating matter. And there is also a mechanism to control that you could open it when and whenever you wanted. But and there's an allowance for removing all residual matter before it enters the main part of the lake, which is at the back in this picture. What from hindsight that I can see, because if I was there, perhaps I also would have done the same thing. Or the rainfall pattern was such that you could do this about 20 times in a year or 10 times in a year and fill the lake. But if you look at the way the weather pattern is there today, you may not get these kind of occasions. So one had to, if I look from today, after 15 years or so, this width of this intake should have been much larger. There's one lesson that we have learned. And of course, by the way of engineering, we could still handle this very easily. The next issue that I would like to bring to your attention is the Belandur and Vartur lake issue between 2008 and 2018, where you suddenly find that the influx of sewage has become very, very high. Some of it is partially treated, some of it is untreated. And one of the interesting things that happened at this flow rate around 2010, 2012, which of course is very difficult to measure, maybe about 150 to 200 MLD was coming as untreated sewage. This is my estimate, but it may not be right. One of the interesting things that we found was that during monsoon, especially in Belandur, the water hyacinth would get pushed towards the outlets, and it would block the channel. It would block the spillway, and the water level would rise quite a bit, sometimes as much as 1.5 feet, which we have noticed occasionally. And then suddenly it would start spilling over the spillway, and all the water hyacinth gets cleared in maybe 1 or 2 such events, and the water surface becomes clear for 4 to 5 months. And what is interesting in that 4 to 5 month period, as you see here in this part of the graph, although during the monsoon the water used to be a little dilute, but a lot of treatment, at least 50 to 60% treatment took place, and occasionally we found even up to 80% treatment when the water was open, which meant that the algae was doing a great job of cleaning up and removing a lot of nutrients. And interestingly, what we noticed that was 1/3 of this lake, as at the shallower end, became anaerobic. It deposited a lot of silt and not silt, sludge, organic sludge, and it remained anaerobic. So a major part of the decomposition was anaerobic, and the output would have been biogas. And the next zone, somewhere around the first half in terms of area and 1/3 in terms of volume, was occupied by a very specific algae called Euglena, which was eating up the bacteria that came out of here, and the turbidity became more clearer. And by the time the water went towards the deep end, you would have a large algal bloom. And if this went into the deep end, well, a lot of fish were growing there. And if this happened over a 3-lake flow, then we estimated that the water would have become really clear. And this gave us a hint that in future, this is the way we could go. Should we have sewage as the only source of water for filling up these lakes? Now, very clearly now in this period, what was clear is when the water hyacinth or the floating macrophytes occupied the surface, there was no treatment that was occurring. That you see towards the beginning January till almost June. The water hyacinth or the floating macrophytes would cover the water body, and completely anaerobic wastewater would come on the spillway. And this showed that the surfactants was in the range of 2 to 11 ppm that came out untreated or undecomposed. And what is important is when this phenomena of the high water flow, the rapid fall, and this poor treatment combination, this gives rise to the foam, and you can recreate this even with 2 to 3 ppm of any of your washing powder in your own house. Around 2005, we had made an estimate that a lot of carbon and nitrogen was getting into this lake, and by about 2020, you could say that this number had gone up 5 times. which means a lot of, if you captured these nutrients and the biogas, this would have made a lot of economic value, but there was no such technology easily accessible. The next experiment or experience I would like to highlight was the story of the Jakur Lake, which has built upon the success model. I don't say they have copied, but there is a very clear similarity that of the Lal Bagh model, where you have first a treatment, wastewater sewage treatment, and then subsequently there is a vetiver bed polishing in Lal Bagh. But in Jakkur, you had an anaerobic treatment plant and a secondary aeration, and only after that it came into the lake. So you need to do some polishing. The advantage the Jakkur lake system had that there was a single inlet, and so control was very easy. And so what was designed was a 2-hectare mixed reed bed, what you see here, with typha and algae. And only then it would enter the 50-hectare water body. And in this part, combined with both typha and algae, the polishing would have occurred. Now, the advantage Jakkur Lake had was that the residence time in the lake was about 90 to 100 days. It was quite deep, so you didn't have too much of emergent weed, but you would have floating weeds. And there was a very disciplined approach of removing these macrophytes almost on a weekly basis. So you find that the lake has been kept very clean, and it has been very welcome to a certain type of birds, and it has become a pelicanry of this place. I understand that there were more than 150 pelicans on a given day at an ideal time. But the bird diversity was very low because you are only looking at deep birds that try to occupy the deep areas. The other advantage was the restricted human activity as well as restricted access, which kept this lake which keeps this lake in this particular pristine position. The last epoch that I would like to say, like to highlight and flag is that today about 280 MLD, million liters per day of treated sewage is going into indirect recharge of various lakes in Kolar. And over a period of time, they plan to transfer about 400 million liters of secondary treated sewage, combined with biological nutrient removal to these Kolar lakes. They plan to fill up 128 lakes, and in such a way that the lakes would be filled, and this would contribute to indirectly to groundwater recharge. And thereon, this would help the farmers in their agricultural activities, and of course, bring back greenery to Kolar. Kolar had been suffering a lot of water shortages over a long time. Today, this is one of the largest kind of systems of this mode of recycling, and today about 75 lakes are filled. What you see in this foreground is the first lake in which water is now entering. The bottom one, A, is where the water, after passing through a pipe for about 70 kilometers, enters this point and exits into the lake and through a channel. And in the foreground is the Lakshmi Sagara lake. And what you see, the quality of water in this bottle here. And subsequently, about six lakes further, that is, there are a chain of lakes over which it flows. Six lakes later, you find a lot of fish trying to get back into the source, almost like salmon. That's a very interesting thing. And if you notice carefully here, you find a lot of cormorants who depend on fish. And this is a clear indication that this water body has now regenerated fish. And what is very interesting also to see in the next picture, unbelievable to see that somebody is growing paddy in Kolar. A district that is known for its dryness, where the rainfall is less than 600 millimeters. So when all these tanks are filled up, the water seepage from below the tank is so much that this has now become good places for growing paddy. This is seepage water coming from below, and also with a lot of fertilizer in that, and this is what is being used for growing paddy. Even bore wells are now functioning like artesian wells where water is coming out on a regular basis. And of course, you can see the paddy and the paddy quality. This is the water, the impact of this water has in some places gone up to as much as 10 kilometers downstream, and some places as much as 3 kilometers downstream. Okay, so what we have learned this far in terms of lessons, what I want to say, and these are experience of others which I'm trying to highlight and show that there's a rich experience within the state of Karnataka on this. One, especially on urban lakes where sewage ingress has been an issue. Raw sewage input, if we had put it once, it would have been okay. But if it's a continuous input, we are increasing the organic and nutrient loads. The organic load creates anaerobic regions, and in sometimes in lakes, when the flow is too much, the whole lake becomes anaerobic. That means it becomes black. The way in which organic matter decomposes changes, so you get a lot of hydrogen sulfide, and that's the fragrance that it always reminds you that you have to do something. The nutrient load, my colleague and Seema, who's been working here, is having a good laugh when I talk about the fragrance of hydrogen sulfide on such lakes. The nutrient loads help the rapid growth of this floating weed, and once it covers, what is the natural reclamation process where algae would grow, put in a lot of oxygen, and sort of battle with the anaerobic condition, that has also been killed. So if we can keep open water or open surface water in these lakes, you can still have some. These lakes can treat a little bit of sewage, and that depends on how the depth is and what is the kind of sunlight that it receives. And these anaerobic conditions for a prolonged period does not allow the surfactants to degrade. And when there is a flood situation or when there is a huge runoff and when they fall over the spillways, frothing occurs. And this has been a highlight. Unfortunately, only the Bangalore frothing has been made into international news. However, almost every city has this legacy of froth, especially in the first flow of, say, after runoff. Delhi has it in Yamuna, Hyderabad has it in various lakes, and so on. Okay, most lakes, what we saw was that they do not get enough runoff to fill the lake, urban lakes especially, since much of the earlier catchment has been diverted in many ways, so the water does not necessarily come into the lake for which it was designed. What is clear that if you're careful, the shortfall can be augmented by treated sewage, and if you can control it, you can keep the water level constant in the lake throughout the year. Because the extent of treatment that one would like to have or what one would like to achieve depends on what kind of a function that you have in the lake. If you increase the nutrients, there's a lot of algae coming in as primary productivity. So obviously, when you have a lot of algae, you need to find somebody who will take away the algae and keep it in check. So which means that in a simple fashion, if you can find some system that can eat away the algae, especially create a food chain, higher productivity will match the growth of, say, zooplanktons, and in turn, it becomes a increased food for the fish, and naturally would bring more birds. So this is what we have been trying to engineer in the Puttenahalli Lake. And of course, one of the important things is you can't have the same uniform depth in a lake if you really want bird diversity. So you need to create niches for different birds and in different forms. One important question that everybody has been asking is, why can't you have drinking water quality in an urban lake? And especially where people would say, I drank water from the lake and I have survived. Water in my lake was we could drink, but why can't we do that in the urban lake? Let me also admit to you that I have drunk water from Hebbal Lake for over 6 months without any treatment, and I've survived. But that was in 1970s when there was no sewage coming in. But the kind of pressures we have and I'm just trying to make a comparison that the lake of the rural areas is generally filled up by runoff over agricultural land. And whereas in the urban setup, it's only partially filled by that kind of runoff. Most of it is from coming from sewage. And the contamination is predominantly sewage and household chemicals in urban system, whereas there is very little contamination in the rural areas, except from uh, runoff from the land, the nutrients from the land, as well as some agricultural chemicals. And these rural lakes are filled only once during the monsoon. And it is influenced by some 500 people. That's a typical small village. Please remember, at once upon a time, we had 45,000 lakes in Karnataka and only 27,000 villages. So each village had at least 2 lakes. So the influence is from 500 people to 150 animals in a rural system, whereas in an urban system, each lake is influenced by about 25 to 50,000 people. So you can imagine the load that's coming, that's likely to come, even if you've taken care of everything else. In the rural kere would have been that it's a steadily depleting source. Once it is filled, say a month of August or September, after that the levels would steadily decline somewhere, and depending on use and not use, anywhere between 2 meters to 5 meters would have been the decline in waters. Whereas in the urban system, it is not similar. And it's not a drinking water source at all. It has stopped being a drinking water source for over a century. Now, the clearing of the lake in a rural setting, the keres were typically the settling of clay, and algae also would also settle down because there were no nutrients at the end of a couple of months. But clay is not the issue in urban system. It exceeds the natural loading potential, and it also is loaded on a daily basis. So please remember that the rural keres were not always meeting the drinking water standards, because when I came into doing research, the first thing I did was to find how to treat rural kere water so that the typical deaths from jaundice and cholera would be avoided. That was my first invention that I made. And that was the kind of situation in the 80s until we brought in something called mini water supplies, which pulled out water from the bore wells. And that is how we have taken care. So if the lake water was often highly contaminated, even in all kinds of rural systems. And it's not true that it was always drinkable, because we never applied drinking water quality standards at that period of time. Again, there's a question, why don't we treat it and make it equivalent of drinking water putting in that? One of the important understanding that comes is that if you put drinking water quality with no nutrients in it, then there is no life possible in the lake, or very little life is possible. And if you start looking at what kind of costing would be involved if you go for a treatment system like a membrane ultrafiltration, reverse osmosis, and then treat the rejects somewhere else, you would be really, for a lake like Puttenahalli, with every hectare would cost you about 75,000 annually, uh, and it would be about close to a 10-hectare lake would be 75,000 daily, and you would be spending about 2.5 crores per year. Forget the operation and maintenance, depreciation, and other risks. So what seems to be the direction to go? See, one of the problems we have is that we don't have a standard for kere water. Now I'm calling kere water, which is nothing to do with lake water. In geographic terms, lake is a part where the river expands to fill up and have a lot of water, and the water is always flowing. Whereas what we have is man-made tanks, and we don't have a standard as to what might be the best. In the absence of that, I think it's best to meet what is possible as the irrigation quality water. And for that, an anaerobic treatment stage will be followed by some little bit of aeration, is the best thing that we can think, and that is what we tried in Putin. Because when you start asking these questions as to how do I bring about eco-engineering to the lake, how do I make everything best, remove the pollutants, make all useful inputs to increase the bird coming there, then a whole lot of questions come in. The nature of questions here is that if I don't get water for 3 years, if I don't get runoff, if there's a drought, how do I keep the water level high in the lake? Now, this obviously tells you that you will have to treat some wastewater somewhere, which is of the nearby water is always generally sewage. And how do I treat it to levels that is required to keep the water reasonably pristine in this lake? Once having done this, how you need to look at how do I create a food chain so that when I bring in a lot of algae or the primary productivity, how do I transform this primary productivity of a lake in the form of algae or something into feed for the birds so that more birds can be accounted for in this lake, can become a habitat for them in the lake. And as very clearly you have, as Dr. Subramaniam mentioned, you have 3 or 4 types of birds. One is the ones that stand on, walk around in this shallow part, one that can wade in low level of water, one that can swim, and one that can dive into deep water and still and lead their life functions. And of course, they will nest in different parts. How do I create those kind of niches? So all these questions become important, and you need to answer them in the design. I'm not going to go over this, but except tell what we have done for the first part, and that the engineering part of this lake, I will bring it out perhaps in the next talk. What we have done is first to make sure that you have removed most of the silt part and gradually increase the depth from the entry here and to the deepest point. Sorry, and then this we have made sure that the sewage that comes gets diverted on a day-to-day basis, so that none of the sewage enters the main body of the lake. So there is a small barrier here, like what you saw in the Agara Lake, and there is an opening which allows the sewage to go away downstream. Should the water level rise above, then it would enter here. Otherwise, on a normal course, it would go away in this channel. And you see from here, what you see the channel that was here, it comes away and gets diverted downstream. So what you need to now have is a balancing weir in which if the lake water level comes down, and only that much water is picked up after treatment into the lake. Now, again, this part of the design, I'll come back next talk. So what you need to have is a treatment system which will look something like this, that you have a balancing reservoir where if the water level in the lake falls, then only then water is picked up into the lake. Otherwise, this water level and the water level in the channel is the same, so there's no inflow at all. Once it comes into the first chamber, this is a deep chamber where there's a lot of sludge, and this decomposes. Most of it is converted to biogas. Somewhere between 70 to 80% of the carbon is removed here and produces a lot of bacteria and particulates that is eaten away by the euglena that grows in the second one. And once euglena grows, what you are left with is nitrogen and phosphorus, and you allow algae to grow here. All of these have typically 1-day residence time. And when algae grows, the pH rises to 9, and both phosphorus settles down. Now ammonia is lost, and pathogens are killed. And now this algae becomes the food for the zooplankton, and system grows. In the top view, what you see is the anaerobic reactor is here. There is an intake, there's a sluice, and the water flows around like this. In the second the third one is the euglena reactor. Again, there's a long path given with a 1-day residence time. And then the third is the algae, and then it goes off into the lake. Now look at the wonderful part that has been done here in the design. There are no moving parts. There's nothing to maintain, and there's hardly any operating costs. So it can accept fluctuations up to 50% plus or 50% minus without getting into problems. And the high pH inside kills most of the thing. The first here itself in the, as you see in the next slide, when a lot of hydrogen sulfide is produced in this particular reactor, biogas exits and heavy metals precipitate. So none of the heavy metals can pass. Here euglena will clear up the water, and phosphorus and ammonia is lost. So what you're doing is you're regulating just enough nutrients to get into the lake. Here the food web begins. The same thing I see. So of course, how to do this? What are the details of this? I'll talk because that is a design issue. I'll talk about in this next. So if you, what is the lessons that we have learned and up to now and how it has been put into manner. As you can see, this is what is the sewage that was there around 2015 and 2016, which has been drained off. And this was the incoming sewage into the lake. Even in these kind of conditions, there are birds. So first thing, we diverted the sewage into an open channel. The open channel is important because we have a lot of particulate matter, plastics that come along with sewage. We don't want it to choke. Only runoff is picked up from this weir, just like the Agara Lake, but here the dimensions are increased. There's a balancing weir that lets in sewage or runoff, lets in sewage into this reactor only when the water level is low. That means only in summer you're going to pick up sewage, treat it and send it inside. The sewage treated has a bare minimum of nutrients, just under 10 ppm of nitrogen and maybe about 2 ppm of phosphorus. And this forms the food chain. Now, this is designed that even for 3 years, if you have no rain, you can keep on using water and the hardness of water or the solids content in the water will not rise. We have fish growing there, which we'll show you in the next talk. Fish have grown to a length of 3 feet. The catfish and the grass carp has grown to about 2 kgs, 2 kgs, little more than 2 kgs. Not the grass carp, so the common carp. And so this clearly shows that this is something, the direction in which we should be going. And there are 3 zones made for different type of birds. The waders, which is a shallow, the ducks and the swimmers where 1 meter deep is there. And for the diving birds, the cormorants and the other birds, we have a deep zone, which is about 2 meters. So you have different types of zones, different types of feeding habits. And of course, the waders also nest in the grasses and the typha that grows there. The fish levels have enhanced, that is what we found. And the same thing has happened even in Kolar. What used to be auctioned at something like 25, 30,000 is now being auctioned at 5 lakhs. So that you can imagine what is the extent of fish increase that has gone. One of the advantages that we have had in Puttenahalli is we have now slowly increased citizen involvement. So a large extent of monitoring, large extent of work is also getting done as a mechanism of participation. Participation becomes important because now we are transferring a lot of knowledge inadvertently and advertently into people who are nearby. So to make things short, we have tried to build a higher sustainability. We try to create a food harmony between the plants, the phytoplankton, and also trying to periodic de-wading. We are trying to increase the types of fish. We have now 4 types. We would like to go to 7 so that all types of problems can be handled. Of course, we keep monitoring the water quality because there's always a fear that heavy metals come into sewage, through sewage into the lake, which has not happened so far. And keep monitoring the food chain, the birds, so that we know what is happening in different parts of the year. So we attempt to maximize the sustainability as well as acceptability for a diverse species of birds. What I would be bringing, this is the lessons that we have learned so far. Now, how this has gone into making the design of the thing, how are the individual elements, how the intake was changed, how the sewage diversion was brought in, on what basis has been the balancing we are made, on what basis was the dimensions of or the open channel for sewage diversion made, what is the basis on which we have chosen various depths, what is the basis on which we have chosen how much food to go in different season, how much nutrients to go to in different season. We are monitoring this and we would like to share this in the upcoming presentations. And how much of what we had planned has been meeting, and these kind of design parameters we would like to be internalizing in a second talk. Of course, This has not been entirely my effort. What you see on this bottom left is my hardworking student, because of which we have been able to collect a lot of data. And like old adage, no, space where no man has ever gone before. I would like to say that lake, sewage lake, where no woman has gone before, Seema has taken that dare and lot of studies. I'm happy for her. I would like to thank, and a large number of people, especially from the Yelahanka Puttenahalli Lake Bird Conservation Trust and the Forest Department, a large number of well-wishers and good friends, Mr. Jairam, Mr. Dr. Punati Sridhar, Manoj Kumar, all of them had placed trust in our trust, and that's how we could move forward. And of course, we have a lot of my colleagues and a lot of my people whom I'm working with are helping out to this. And one of the best advice we got was from Professor Ram Prasad to create that balancing wave, and that's one of the unique things that we found in. It has been working very well for us. We don't have to go and see how much water to put every day. It naturally takes care of that. Professor Ram Prasad was the one who sort of cleared our designs and made sure he was with us. Thank you, everybody. Thank you, Das, and thank you, Sanguni. I hope I have made an opening statement about the kind of experience we have had in the state and how we have been using that into various aspects of designing Puttenahalli Lake.